In this video, we're going to see rule number 4 of root locus construction in control systems. And this is based on angle of asymptotes. As we have seen in rule number 2 of root locus construction technique, that when k parameter is varied from 0 to infinity, the roots of characteristic equation are going to start from open loop poles and end at closed loop, open loop zeros. And the number of branches which are not ending up at open loop zeros, they end up or tend to infinity along the asymptotes specified by the angle of asymptotes, which we are going to discuss now. So these n minus m branches which are going to infinity, they're going to go along the angle of asymptotes, which we are going to see. Okay, so the conclusion is n minus m branches are going to go to infinity. Okay, and the angle in which they're going to go, we are going to derive it now. Okay, before that, let me discuss an example. uh, let me take an S-plane like this. Okay, and let's say I have a pole 0 configuration pointed out like on this plane. Okay, -1, -2, -3. And suppose I'm going to take a point, say here, which is like I'm going to take it as P1, and let's assume this P1 is going to be on the root locus. Okay, then if I make lines from each and every pole in this configuration and 0, then the angle made by these poles, say phi 1, okay, here phi 2, here phi 3, okay, and if this P1 is far away, then this phi 1, phi 2, phi 3 will be approximately the same. And if this P1 goes further away, okay, and assume that this P1 is present on the root locus, then these then the angle condition and magnitude condition will be satisfied if this P1 is on the root locus. That's the whole point of saying it is present on the root locus, right? And now if it is going far away, then for sure this phi 1, phi 2, phi 3 are going to be nearly equal. And suppose this P1 is tending to infinity, then all these angles will be approximately equal. Okay, phi 1 equals phi 2 equals phi 3 equals to, let's take a value phi. Okay, this is the basis on which we will build this angle of asymptotes, or we'll prove the angle of asymptotes here. Okay, now let's take open loop gain or open loop g of s h of s. We have m zeros and n poles. Wherever this m zeros or this n poles are located on the s-plane, if we have a point present on the root locus which is tending to infinity, then the angles made by the zeros and poles are going to be same to that point as the point is tending to infinity, as we have seen in this particular example. Okay, so then the total or the net angle contributed by this poles and zeros of this g of s and h of s, we can write it as m times phi, which is the angle contributed by the zeros of this function, minus n times phi, this is the angle contributed by the poles of this g of s h of s. This will be the net angle contributed by g of s and h of s. Let me take phi common, then it becomes m minus n times phi. Okay, we can write this back again, minus of n minus m times phi. Okay, this is one important result here. Now we know that if this is the case and this is the angle made to that particular point which is tending to infinity, and we assume that point is present on the root locus, then it should satisfy the angle condition, which means this minus of n minus m times phi should satisfy the angle condition. And we know the angle condition, which is plus or minus 2q plus 1 times 180 degrees, and here q can take integer values including 0, 0, 1, etc. so on. But now here there is a limit to this q values, how many it can take. Okay, now rewrite this expression as we have some values here. So this phi will be equal to plus or minus 2q plus 1 times 180 degrees divided by n minus m. Okay, this phi we're going to see and rename this as phi a. Okay, this is like angle of asymptotes. Okay, or you can have any other name which suits you. Okay, we have seen that n minus m branches are going to tend to infinity. In that case, we should have this phi angles, angle of asymptotes. The number of angles which we are supposed to get will be equal to n minus m. Okay, so it means q can take values 0, 1, etc. so on till n minus m minus 1, because these are the number of, okay, uh, branches of the root locus which are tending towards infinity. Fine. Or these are the number of branches that are terminating on infinity. So finally, let me write the final formula once phi a equals 2q plus 1 times 180 degrees divided by n minus m, and whereas q can take values 0, 1, etc. so on, n minus m minus 1. Thanks for watching the video. If you have any questions, send me a message and please do comment below the video. And thanks for watching again.